Welcome back. Now it's time to talk about two-dimensional motion, and this is where things get really interesting. So far, we've only talked about one-dimensional motion, and that's motion in a straight line, either purely up and down motion or purely left and right motion. But what happens when we have some combination? Well, then we get the motion we're familiar with. This is the sort of motion that describes a cricket ball as it bounces towards the batsman, or an arrow as it sails towards its target, or a parachutist who's just jumped out of a plane. Now, before we talk about our modern-day understanding of two-dimensional motion, and in fact Galileo's understanding, let's talk about what Aristotle thought of two-dimensional motion. In Aristotle's mind, and this is Aristotle over here, of course, objects, for example a ball thrown into the sky, move in a straight line until they run out of what he called impetus. At that point, the object will fall straight down and land somewhere on the ground. Now, before you continue, why don't you try this? Throw a small object like a coin or a pencil in front of your field of view, and look at what you see. It's actually really difficult to see what's going on. In fact, it wasn't until Galileo came around that the true path of an object in two-dimensional motion was known. That path is what's called a parabola. So we know that two-dimensional motion is parabolic. But so what? Parabolic is just a word. What does it mean? In fact, can we use this word to somehow describe two-dimensional motion mathematically? In physics, prediction is power. And what I mean by prediction is, can we develop our understanding of motion in such a way that we can explain and predict mathematically how an object will move before we actually throw that object, let's say? We can, and that's what we will do in the rest of this unit.